So today we are going to solve GFG problem of the day, that is Floyd Warshall. So you are given a weighted graph represented by adjacency matrix this of size n cross n, where dist of ij represents the weight of the edge from node I to j. So let's suppose if node I is 0, node j is 1, then this particular thing represents 4. So this represents weights between any two particular node. So I will explain this later. The graph may contain negative edge weights, but it does not contain any negative weight cycles. So it means it could be having negative weights, but it won't be having negative weight cycles, so that it won't be going into the infinite loop. Your task is to find the shortest distance between every pair of nodes I and j in the graph. So let's suppose if this graph is given. So it has 5 nodes 0, 1, 2, 3, 4, and it is a directed graph. 0 is pointing towards 1, 1 is pointing towards 4, 3 is pointing towards 4, and it has weights in between as explained in the question. So let's say if you're supposed to find the distance between 0 to 4, so we would consider the direct path first, that is 1, and if you will go via 1, that is this 0 to 1 and 1 to 4. So 0 to 1 and 1 to 4 would be 4 plus 6, that is 10. And if you will go via 3, that would be 0 to 3 and 3 to 4, and it will be having 5 plus 2, that is 7. So taking all the paths, you will take this as minimum and you will consider this. So like this, you're supposed to find all the possible paths that should be minimum, like 0 to 3, 0 to 2, 0 to 4, 1 to 3, let's say. So you will explore all the paths and you are supposed to find the minimum value among all them. So I will explain this side by side via C++ code. So initially you are given dist. I will initialize its size as n, and I will iterate. Okay, so here I will consider this midpoint as k, that is I to k and k to j. It's like that. So first I will iterate through all the possible k values that would be till n, and on the same way we'll explore all the initial point we are supposed to find till all the destination, that is j. And once we have explored all the paths, we'll put some condition. If dist of ij is infinity, I will explain this, or dist of kj is infinity. My bad, it should be k. So it means if you are given from 0 to 1, it is given as 4, but 1 to 0 nothing is given, right? So we'll consider all those cases and we will declare it as infinity, and there's no point adding something to infinity, so it will anyhow give infinity. And if it falls under this category, you will continue, and at last you will write something as distance of ij equal to minimum of distance of I and j, or distance of I to k, as I explained before, plus distance of k to j. It makes sense, right? Let me try to run it. Okay, I will directly submit it. It should run. So thank you.